In this video, we're going to talk about functions. So we're going to talk about almost everything about functions, relations, inverse of functions, quadratic, the domain and the range, the types of functions. So this will be like our full roadmap. We are literally going to talk about everything on functions, how you sketch them, how you solve equations, piecewise functions, polynomials, basically that. So now, without wasting much of the time, for us to understand functions, what are some of the basics? Okay, so to understand functions, we first need to understand what we call relations and mapping. Others will call it mapping. Now, let's say we have a set x and y, and let's say in x we've got elements 1, 2, and 3, or like that. Then let's say in y we've got a, b, and c. Now this will be a function only if all the elements in x are mapping to some element in y. So if we're going to, let's say this is x, this is y, and we put the values for x, we've got 1, 2, and 3. Then we put the values for y, we've got a, b, and c. Then let's say the relationship between these values is that 1 is going to a, 2 is going to b, and 3 is going to c. This will be a function because every element of x has an element in y. Now, what we should understand is that the set of those x values and the y values, they've got different names. So the set of x values are called the input. The set of y values are called the output. Now, the specific name we give to the input values, in this case we're talking about the x values, we call it the domain. Then the output values, which are the y values, we call them the co-domain. Now, domain and range, they're a bit different. I'm going to explain later on as we move on. Okay, so let's just illustrate this further. Let's say I've got 2 and I've got 3. Then I've got A, I've got B, and I've got C. Then the relationship between these values is that this is going to that, this is going to that. Now, is this going to be a function or not? Considering that these are the x values on my left hand side and these are my y values on my right hand side, is this going to be a function? Definitely, of course, this is still a function. You can have a value in the output not relating to anything in the input. Okay, it is still a function. Let's put another scenario. Let's say I've got 3, this is x, let's say this is y. Then I've got b and I've got c. The relationship between these ones is that 3 is going to b, 3 is also going to c. Is this a function or not a function? So this is not a function. Why? Because we've got one x value, we've got one input value that is giving us two output values. So this is not a function. Let's put another one. Let's say this is the x and this is the y. For the x, let's say we've got 1, 2, and 4. Then for the y, let's say we've got a and we've got b. Then the relationship between these ones is that 1 is going to a, 2 is going to b. Is this a function or not? So this is not a function. Why? Because we've got one input value that is not mapping to anything. So basically that. Let's put another scenario. Let's say I've got, these are the x and these are the y values. For the x values, I've got 1, 2, let's say 3 and 4. Then for the y values, let's say I've got a, b, and c. Then the relationship between these values is that 1 is going to a, 2 is going to b, 3 is going to c, 4 is also going to c. Now, is this a function or not? So this is a function. You remember your quadratics? So you can have two x values that are giving you y value, one y value. If we say x squared is equals to y, that is a quadratic. Or we say, you can even put it like f of x is equals to y is equals to x squared. This is still a function. Or if we even put plus 1, it is still a function. Okay, so basically that. However, the opposite is not true. Where you have one x value, it's giving you y squared. No, this is not a function. Like a scenario where we had let's say you have 3. This 3 is giving you, let's say, b. It is also giving you, let's say, c. So this is not a function. So basically that. Now the relations that are, there are relations that are not functions, like we've said. So a relation that is not a function, like we've said, like let's say a is going to 1 and 2. In this case, this is not a function. This is called a one-to-many. One-to-many is not a function. We've got one x value that is giving us too many outputs. In this case, two outputs, 1 and 2. This is not a function. Another relation that is not a function is where you have an input without an output. So for example, a good example that you can put is, let's say we've got a, we've got b, and we've got c. Then a is going to, let's say, 1. Let's say c is going to, let's say, 4. In this case, this is not a function because we've got one input value that is not relating to any x, any y value or output value. So basically that. Now we've said you can have the x and the y. Now what's the difference between these ones? If we're now going to put it into context. So if, let's say, x I've got 1, 2, and 3, then for y I've got a, b, and c. And the relationship between these ones is that 1 is mapping with a, 2 is mapping with b, and 3 is mapping with c. All the y values are mapped to some x value, and all the x values are mapped to some y value. So the x values in this case, this is going to be called the domain. Then, since all the y values are mapped to some x value, this is what we call the range. Because all y values are related to some x value. That is very important. Now, to just even clarify it further, so that is a domain there. But now, if let's say we put another value here, let's say we put d. Okay, is this a function? Of course it's still a function. Why? Because all the x values are mapped to some y value. But now it's just that not all the y values are mapped to some x value, because we have a d which is independent there. However, it's still a function because you can have an output value without an input value. So we will no longer call this one as a range, but we'll call it the codomain. Okay, basically that's very important for us to understand that. Now let me just wrap what I've just written. Now if we have this function, all the elements in x have got some element in y, such a function is called a one-to-one. So we're able to see that each x value is at least mapped to one y value. Every x value is mapped to some y value. This is called a one-to-one function. Now, this one-to-one function, you can also call it an injective function. So that is very important for us to know. Then let's say I've got x, I've got y. I've got, let's say I've got 1, 2 and 3. Okay, let's say I've got a, b, c and d. Now the relationship between these ones is that 1 is going to a, 2 is going to b, 3 is going to c and d. Is this a function? Of course, all the x values are mapped to some y value. However, we've got one x value that is mapping to two y values. That is giving us two outputs. So, is this going to be a function? No, it's not a function. Like we've said, if you can't have one x value that is giving you two output values. So this is not a function, but it is a relation. That is very important too. It's just a relation. Now, what is the name of this function? This is going to be called a one-to-many function. One-to-many. For the sole purpose that one x value is giving you too many outputs. That's why we're calling it one-to-many. Now, let's also put another one. Let's say you have x and you have y, like that. Now, let's say you've got 1, 2, 3 and 4. Let's say this side I've got a, I've got b and I've got c, like that. And the mapping between these ones, it's 1 is going to a, 2 is going to b, then 3 and 4 are going to c. Okay, now this is like the opposite. So what is it going to be called? So many x values or two x values are going to one output. So this kind of a function is going to be called a many to one. Why many? Two are going to 1. So you are always considering starting from the x values. So this function is what we call an onto function. Some literature are going to call it a subjective function. So a good example that we can give is that we can have one x value, but it's giving us, we can have two x values that are giving us one value. For example, if I square, let's say 1, and we can have this scenario where I've got -1 and +1. If we square them, they can all of them give us 1. Okay, they're giving us one value. Same, I can have +2 and -2. So if we square these ones, they can all give us a 4. So able to see that two x values are giving us one y value. That still exists. Okay, so now to put it into much context, let's say this is the x, this is the y. Then let me say this is -1, -2, -3, +1, +2, +3. Then here I can put the y values that we have. Let's say I can have 1, I can have 4, I can also have 9. So now what would be the mapping between these ones? So which numbers, when we square them, they're going to give us a 1. So when we square 1, it is going to give us that 1 here. It's going to give us 1. When we square also the +1, it will also give me the 1 there. Now when I square -2, it will give me 4. When I square +2, it will also give me 4. When I square -3, it will give me 9. When I square 3, also it will give me 9. So basically this is what we are talking about. Two x values giving you one y value. Okay, basically that. So this is about relations. Now how do we show that a function is a one-to-one? Okay, so one-to-one functions. So let's say I've got f of a. It is only one-to-one if f of a is equals to f of b. So how do we mean? For us to show that the function is one-to-one, f of a should be equals to f of b. Okay, so an example that we can give is, let's say we have f of x. This f of x is equals to 4x minus 3. Now then we're saying a function is only one-to-one if we have got, let's say, f of a is equals to f of b. That's when it is the same. So basically, if in this equation we solve for f of a, we find the answer, and in this same equation we solve for f of b, then we compare the answers. If those answers are equal to each other, then that function is a one-to-one. So let's solve this. F of x is equals to 4x minus 3. So now what I'm going to do is that I'm going to equate both of the equations. So where there is x, I'm going to put f of a. Where there is x, I'm also going to put f of b, and I'm going to equate them to see what we're going to have. So let me start with 4. Where there is x, I'm putting a minus 3. This should be equals to f of b, so it will be f 4b minus 3. Now that we've got this, we just need to solve. When I take the negative 3 to the other side, it becomes a positive number. So our 4a is equals to 4b minus 3 plus 3. Minus 3 plus 3 will give me a 0. So I'm just going to remain with 4a is equals to 4b. Now I can divide the 4 on both sides. So when I divide the 4 on both sides, you're able to see that I'm remaining with a is equals to b. So a is equals to b, meaning this one is a 1 to 1. Let's solve another one. Let's say f of x is equals to 4x plus 2 over, let's say 3 minus x. So for this to be a 1 to 1, f of a should be equals to f of b. Now, what is our function? Wherever there is x, we're going to be putting a. So we're going to say 4a plus 2 is equals to 3 minus x. I'm now going to equate this to f of b. So it will be 4b plus 2 over 3 minus b. Then after I have this, I just need to now solve. For me to solve, I just need to now cross multiply. So I can cross multiply this one and like that. So let me start with the 3. This 3 is going to multiply with that is in the bracket. Now the 3 multiplied by the 4b, it will give me 12b. The 3 multiplied by the 2, it will give me positive 6. Then now I'm going to come to the negative x multiplying with this expression. So negative x multiplied by 4b, that will give us negative 4xb. Then the negative x multiplied by 2, that will give us negative 2x. Then I come to the other side. I'm also going to do the same, this multiplied by that. Okay, so I can start with okay, still the same. So 4a multiplied by 3, I'm going to have positive 12a. 4a multiplied by negative b, I'm going to have negative 4ab. Then I come to the 2. 2 multiplied by the 3, that will give me a 6. That will give me a 6. Then 2 multiplied by the negative b, I'm going to have negative 2b. 2b like that. Okay, allow me to just erase this one nicely. I'm going to have negative, this was 6, yeah, just 6. Then I'm going to have negative 2b. Negative 2b like that. Now that I've got this, what do I now do? Do we have expressions that are okay, that are equal? Okay, of course not. So where did I, so since we're cross multiplying, I've forgotten to put an equal sign. Where am I putting the equal sign? Is it here? They're supposed to be 4 each. Yes, so here I'm supposed to have an equal sign, because when we went this side, we multiply that, it gave us this whole expression. Okay, so I didn't put the equal sign. Apologies for that. Now like this, now what do we now do? If I take let's say this positive 6 to the other side, it's going to cancel with this positive 6, because one will be negative, so this is going to cancel. What else is going to cancel? Okay. So we've got negative 4ab, this is ab, and negative 4ab on the other side. What are we going to? So this is also a this side. Wherever there is x, we are putting a. So negative 4ab and negative 4ab on the other side, they're also going to cancel. So now, basically, what do I now remain with? What am I remaining? I've remained with 12b minus 2x is equals to 12a minus 2b. Okay, so this is what I have. Okay, now when we solve, what do we now have? So I don't know where I'm okay, this is a, there's no x there. So I'm going to take the negative 2b on the other side. I'm going to put the like terms together. So this side I'm going to remain with 12b. When the negative goes on the other side, it becomes positive 2b. This will be equals to 12a. When the negative 2a goes on the other side, it becomes positive 2a. Now 12b plus 2b, that is 14b. This will be equals to 12a plus 2a, that will give us 14a. Then now, when you divide by the 14 on both sides, I'm just going to remain with b is equals to a. So this is also a one-to-one function. So basically, this is how you show that a function is one-to-one or not. However, if a and b are not equal, then the function is not a one-to-one. Now, let's talk about injective, subjective, and bijective functions or relations. So for an injective, we've said if I've got x and y, let me also put for the subjective, if I have x and if I've got y, the bijective x and I've got y. Now for the injective, okay, so for the injective, if I've got, let's say 1, 2, and 3, then let's say we've got the outputs as A, B, C, and D. So injective, this is just going to map like that, and like that. All the x values are mapped to some y value. Okay. Now for a subjective one, if I've got 1, 2, and let's say 3, then I've got A and B. So this is also called an onto function. So 1 is going to A, then let's say 2x values are going to 1 y value. This is called the many-to-one function. It's called an onto function. It is also called a subjective function, or a relation like that. Now for a bijective, if I've got, let's say 1, 2, 3, and 4, then let's say the y values, I've got A, B, C, and D. Then how are these ones mapping? So 1 to A, 2 to B, 3 to C, 4 to D. No value is left alone for a bijective. For an injective, you're able to see that one y value is left. But for a bijective, all the y values at least also have some x values. So this is the difference between these three. Now I'm talking about this because you cannot find the inverse of a function that is not bijective. So for you to be able to find the inverse, which we're going to talk about, for example, a quadratic function, we are saying a quadratic function is a function, but now for you to find the inverse of such a function, which gives you it's able to give you like two x values that are giving you one y value. For example, if we square the x values, they're giving us one y value. So you need to restrict the domain, and we're going to talk about quadratic functions in this same video. Now, how do you find the inverse of a bijective function? Okay, we know that the inverse usually reverses the output of a function. So if let's say I've got let's say f of x, let me use this. Let's say I've got f of x. Let's say this f of x is equals to 3x minus 1. You know that f of x is the same as y, right? I'm saying f of x is just the same as the y values. So in this case, for me to find the inverse, I'm going to, this f of x, let me put y. So y will be equals to 3x minus 1. Then I'm going to make x the subject of the formula in this case. So for me to make x the subject of the formula, I'm going to take the negative 1 to the other side. When I take the negative 1 to the other side, I'm going to have 3x is equals to y plus 1. Then for me to remain with my x, I'm going to divide by 3 on both sides. So the 3 and the 3 are going to cancel. So I'm going to have x is equals to, y plus 1 over 3. Okay, so this is what I have. Now where there is y, I'll put x. So this is now going to read, then where there is x, I'm going to now put the inverse function. So I'm going to put f inverse of x is equals to, where there is y, I'm going to put x plus 1 over 3. This is how we find the inverse of a function. Now let's solve another one. Let's say you have f of x is equals to x plus 1 over 3 minus 2x. So y will be equals to x plus 1 over 3 minus 2x. So since this is what we have, we're going to cross multiply. So I'm going to cross multiply like that. So on my left hand side, I'm going to have x plus 1 is equals to, the y now is going to multiply with 3 minus 2x. Y minus 3, that is 3y. Y multiplied by 3, that is 3y, minus 2x multiplied by y, that will be 2x y. Now that I've got this, what do I now do? I think I can now put I can put the like terms together. So I can do, I'm going to take this 3y to the other side, then the x is going to come to where the x is. So I'm going to have or let me take the negative 1 to the other side so that I avoid negatives. Then I take this negative 2xy to the other side. So I'm going to have, this side I'm going to have 3y minus 1. This side I'm going to have x plus 2xy. This is what I have. Now I'm supposed to make x subject to the formula. So it means first I need to factorize this expression. You're able to see that x is common on both sides, so I'm going to remove the x. Where there is x here, it will have 1 plus y plus 2y is equals to 3y minus 1. For me to remain with my x, I'm supposed to divide by 1 plus 2y on both sides. Therefore, my x will now be equals to 3y minus 1 over 1 plus 2y. So basically that is our function. Now for us to fully now express it or write it as an inverse function, where there is x, we're going to put f inverse of x is equals to, then where there is y, in our answer we're going to put x. So this will be 3x minus 1 over 1 plus 2x. So this is how we find the inverse of a function. Now let's talk about odd, even, and neither functions. Okay, now every time you've got let's say we are saying f of x is just the same as y, so don't forget that. Now if I've got f of negative x, then this is giving me f of x. This is called an even function. Then if I've got let's say I've got f of negative x, this f of negative x gives me a negative function, negative f of x. This is odd. It's an odd function. Then if you find that none of these is true, such a function is neither odd nor even. In other words, it does not satisfy any of the conditions that we've just displayed here. Now how do these ones come about? If we're going to start with an even function, so a function that is unchanged when reflected above the y-axis is what we call an even function. For example, f of x is equals to x squared, a quadratic function. Now whether you change the sign of the x, you still have the same y value. For example, let's say x is 1 and we square it, 1 is going to give us 1 still. And the same x, let's say we put, now it's negative, then we square it, it's still going to give us a 1. Such kind of a function is even. So if you're going to plot this on a graph, how is it going to look like? So let's say this is our graph. Let's say this is our graph like that. Then on our graph, let's say which base number can we pick? Let's say I've got negative 3 here, and let's say I've got positive 3. Then let's say I've squared 3. 3 is going to give me what y value if I square it? Let's say 9 is there. It's going to give me a 9 on the other side. At the same time, if I square positive 3, it's also going to give me a 9 there. And let's say this point is passing through 0, 0. That's where we're starting from. If we're going to join this, if we join these lines, it's going to be something like that. That is our quadratic. Now, what are we able to see here? If I'm going to write these points that we've just displayed here, the point here, it is negative 3, 9. The point on the right hand side, this is positive 3, 9. So what you're able to notice is that whether we change the x value, we are still getting the same answer, which is 9. Okay, that is an even function. Then for an odd function, for it is going to be a bit different. And x squared, 2 is an even number, so basically that's how the function goes, like that. But if we have f of x, let's say it's giving us a cubic function, okay, x to the power 3. 3 is an odd number, so basically how is it going to look like? Let's say this is our x, this is our y and our x axis. So it's going to come here, then it's going to be reflected like that. That is how your cubic function looks like. So basically that. So that is an odd function. Now to just cement this, let's solve some questions. So let's say if I've got f of x, let's say is equals to 2x squared minus 3. Now even before you even solve, you're able to find whether it's even or odd, but you still need to solve. So let's look at the powers of x. Like we've said, if f of x is equals to x squared, that is an even number, okay? So basically it is going to give us an even function. But let's prove. Let's look at the powers of x. Since here we don't have a power of x, if I'm going to put x there, I can put it to the power 0. Any number to the power 0 is 1. 1 multiplied by 3, I'm still going to retain my 3. So basically you're able to see that the powers of x, this is power 2, this is power 0. Then if I'm to ask 2 and 0, are they even or odd numbers? So 2 numbers like 0, 2, 4, 6 and going like that, those numbers are even numbers. So because the powers of x are even, you expect the function to be an even function even if before you even show. Okay, so now let's solve. So we're saying f of negative x should be equals to f of x if you are solving for an even function. So what this means is that where there is x, we're going to put negative x. So let's get our function, which is 2x squared minus 3. Okay, so we're saying f of negative x should be equals to that. So now if we solve this one, what are we going to have? Wherever there is x, we're going to put in negative x squared. That's what that means. So I'm going to have 2 negative x squared minus 3. Now if I solve this, what do I have? So this is f of negative x, f of negative x. 2 negative x squared, what is it going to give me? It is going to give me x squared. Okay, then minus, I'm going to have my minus 3 there. Now you're able to see that this is the function. Then in as much as we put even a negative number, we're still retaining the same function, which is f of x. So basically because of that, it is still giving us the same y value or the same value of y. So those ones are the same even after we had to replace a negative x. So because of that, this is going to be an even function. Okay, let's solve another one. Let's say this time around I've got f of x is equals to 2x to the power 3 minus 3x. Now look at the powers of x. Both the powers of x are odd. 3 is an odd number, 1 on power x there is also an odd number. So we're expecting to have an odd function. However, let's solve. So f of negative x should be equals to, before you find for an odd number, try to check if it is an even number. Okay, so wherever there is x, we're going to put negative x. So it will be 2 negative x to the power 3 minus 3 negative x. Then we solve. So if we solve for this, 2, now negative x to the power 3, you know that it is just going to give me a negative, right? So in this case, I'm going to have negative 2x to the power 3. Then negative 3 multiplied by negative x, that will give us positive 3x. Now we're able to see that this f of x, and if we're going to look at the f of x that we have is this one, but this one is not equals to the answer that we found, because this has a negative 2, this one has a positive 2, so they are not equal. So because of that, this is not even. Since it's not even, I'm going to get the same expression now and factorize to see if it's going to become an odd function. So basically I'm going to have f of negative x, then if I factorize a negative 2x to the power 3 minus 3x. Now you're able to see that this, the one that we've now written, after just now simplifying by factorizing, you're able to see that f of negative x now is equals to, we have the negative here, I'm going to put the negative here. Then what we have in the brackets, this, it is the same as f of x. Okay, so basically I'm going to put f of x in brackets, and this is how we see, this is how we illustrated that. That's how we find for an odd function. So because we found that it is giving us a negative expression, this is an odd function. So basically this is how we show that a function is either odd or even. Then if it doesn't satisfy any of those conditions, then it's neither. Okay, now let's talk about how to find the domain and the range. This is one of the most, one of those topics that gives a lot of people challenges. How do you find the domain of a function, and how do you find the range of a function? Now we already know that the domain is a set of x values, the range is a set of y values of a function. Now if we're talking about the domain, you want the values of x that will make the function defined. As we progress, there are some expressions that are going to make the function undefined, and such values we normally exclude them. Okay, undefined, for example, I say 2 divided by 0. We don't know what 0 is. Okay, so because of that, this is undefined. You can punch that on your calculator. But if we say 0 divided by 2, this will give us an answer 0. You can try that on the calculator. So we only want values that are going to make the function defined. So that's what we are calling the domain. Now we're going to talk about the domain of all kinds of functions. The domain of a linear function, the domain of a quadratic, the domain and the range of a rational function, the domain and the range of we can talk about a radical function. Okay, just to put it into context. So how do you find the domain of a linear function? Now a linear function, this function is in the form of y is equals to mx plus c. This is the form. So if I've got the function, let's say f of x, this is equals to 2x, let's say minus 1. The domain for such a function, which value of x here can make this function undefined? So we're going to realize that the domain for the function in this case is a set of all real numbers, because everything is going to exist. Okay, this just means that there is no value of x or even y in this case that you are able to place in this function, and then you get a result which is undefined, meaning it exists for anything. Now if it exists for anything, what is it going to, how are you going to show that? So the domain for this function will be equals to, in this case, all real numbers. Okay, the range for this function is also going to be all real numbers. Real numbers are all the numbers that you can think about in your head right now: positives, negatives, fractions, decimals, except numbers like complex numbers. Okay, basically those ones. Otherwise all the numbers are going to be real numbers. Okay, so everything on that line is going to exist. And if you are even going to maybe to plot this graph, if we're going to plot, just to show a quick one, so if we're going to choose x and y values, let's say this is x, this is y. Let me pick a negative number, -1, 0 and +1, and replace in this equation. So if I put a -1 there, I'm going to have -2 minus 1. That will give me a -3. If I put a 0 here, 0 multiplied by 2, that will give us 0. Then I'm going to remain with 0 minus 1, that will just be a -1. Then if I put a 1 here, it will be 2 multiplied by 1, which is 2. Then 2 minus 1, that will be a 1. Now this is what I have. Now I'm just supposed to plot this on the graph. So x, I'm saying I've got -1. I also have 0, then I have +1 there. Then for y, I've got -3. Let me put -3 here, or -1 and 3 there. Then I can put 1 there. Basically that. Then let's plot 1, -3 is somewhere here. Then 0, -1 is probably maybe somewhere there. Then +1, 1 maybe somewhere there. So able to see that this is just going to be a straight line going like that. On a straight line, everything exists. All the y values are existing, all the x values are existing. In this case, you're getting all the numbers. You're not leaving anything because it's a straight line. So you join all the points, it's just going to be going in that direction. Everything is going to exist. That's why I'm saying it exists for anything. Then if we're going to talk about a quadratic function, for a quadratic function, a function in the form of f of x, let's say, is equals to, we can put x squared plus 1. So since, if you're going to look at, if you put any value of x here, whether negative or positive, we're still going to get a function that is defined. So because of that, even the domain for a quadratic function will be all real numbers. So x will be a member of all real numbers. Now you can also write this as, because it's all real numbers, you don't know where they're starting, you don't know where they're ending. So that is from -infinity to +infinity. You can put it like that as the domain. Or you can also put it, x is between -infinity, or x is less than, x is greater than -infinity, and x is less than +infinity. You can also put the domain like that, however you want it. However, for the range is going to be a bit different. You have to first solve for y. Okay, you have to solve for y. So how are we going to solve that? So we're going to say y is equals to x squared plus y. Mind you, y, these are the these are the y values, okay? Then x, those are the input values. So you have to first find what the output values are for you to find the range. So in this case, what is going to be our answer? Okay. So if we're going to, you know that on the y-axis, x is equals to 0. So 0 is equals to x squared plus 1. Now if I take 1 to the other side, what am I going to? I'm going to have negative 1 is equals to x squared. Then if I square root on both sides, look at what I have. I'm having a negative answer as a square root, and you don't want to have a square or a root with a negative number in there, okay? So because of that, the range is going to exist for everything. So what do? We are supposed to find the inverse of this function. So the inverse of this function, it means we're going to make x a substitute formula, right? So I'm going to have y minus 1 is equals to x squared. Then for me to remain with x, I'm going to square root on both sides. The square and the root are going to cancel, so x will be equals to the square root of y minus 1. Now you get what is in the root here. It shouldn't be equals to a negative number, so y minus 1 should not be equals to a negative number, okay? So in this case, it should not be equals to 0. So in this case, y should not be equals to, when I take the negative 1 to the other side, it's going to be a positive 1, okay? So we don't want a negative 1, a negative 1 in there. If so, y should be greater than or equal to 1. So basically this, so the range for the quadratic therefore will be y should be greater than or equal to 1 actually. So what this means is that we can have a 1 here. Why I've put equal to is because we can have a 1 here, it's fine, it will give us 0. The square root of 0 is 0. But if we get any number like greater than 1, let's say a 2, we'll still get the square root of 1, which is just 1. But if we get any number that is less than 1, let's say a 0 here, 0 minus 1 is going to be minus 1, and we have a square root of a negative number, and that's what we don't want. That's why we have to go back and find the inverse. So we're able to see that negative 1 going all the way to the negatives, they are not going to exist. So the range, the y values that you want are all numbers that are 1 or greater. Basically that would be the range for this function. Then how do you find the range and the domain of a radical function? Now the question that we are just from solving, it has given us a glimpse of what the radical function is. So a radical function is a function that has a root, okay? Let's say f of x is equals to the square root of 1 minus 2x. So 1 minus 2x. So the inside should always be positive, the inside of the root. We know that the square root of a negative number is a complex number. We don't want to have a negative number in here. So what are we supposed to do? So if you want to find the domain for this function, let's start with the domain. Just get what is inside the root, and so we're going to say 1 minus 2x. This should be greater than or equal to 0. Why are we saying should be greater than or equal to 0? Yes, you can have a 0 here, it's fine, okay, but you don't want to have a negative number there. So you want all the numbers that are greater than 0, like 1, 2, 3, like that. Then you solve. So it will be 1. If I take the 1 to the other side, I'm going to remain with negative 2x is greater than or equal to negative 1. For me to remain with my x, I'm going to divide by negative 2 on both sides. Now, just to remind you, every time, you remember your inequalities, every time you divide with a negative number, the inequality symbol changes, so it's going to face the other direction. Okay, then negative 1 divided by negative 2, that will just give us a half. Okay, so we want all the values, so x is less than or equal to half. Okay, so in this case we want all the real numbers, and those real numbers are specifically those where x is less than or equal to half, basically that. So if you are going to show it in terms of so the domain for this function will be equals to x is such that x should be less than or equal to half. So it means you're going to the negative numbers, or x is, and this x actually you can put it, and this x, you can put a comma here, is a member of real numbers, okay, because we're getting almost all the numbers. Then, or you can also put it in terms of, you can present the domain in different ways. Okay, this negative, you want you can put negative x but half. Okay, you can include half is equal to there, but want all the negative numbers of x going in that direction, so we can put negative infinity here going in that direction. So basically that is also how you show the domain of such a function. Now maybe if we have another radical function, let's say f of x is equals to the square root of let's say 1 minus x, 2 minus x. So what are we going to do? Every time we go such, we don't want a negative number in there. So for this time around, since there are two equations, so I'm going to say 1 minus x, 2 minus x, this should be greater than or equal to 0. Then I'm going to equate these functions to 0. So 1 minus x, this should be equals to 0. 2 minus x, this should be equals to 0. X is equals to 1 in this case. When the 1 goes to the other side, becomes negative. Then I have a negative. It divides. I'm just going to have a positive 1. Then for the other one, what am I going to have? I'm going to have x is equals to 2. Because when the 2 goes to the other side, it becomes a negative 2. Then when I divide by the negative on the x, I'm going to have a positive 2. So basically that. Now, for this one, because of what you have, you'll be required to come up with a table of values. So for a table of values, let's say this is our let's say this is our table of values, like that. Okay, we can put it like this, like that, and like that. Okay, so this is what we have. Now what answers? We've got 1 and 2. Those are our answers. So I'm going to put 1 here. I'm going to put 2. Now which numbers gave which equations gave us this? So we got equation number where we are 1 minus x. The other equation is 2 minus x. Then we're going to find, because these ones are multiplying them, they are multiplying, we're going to, at last we're going to find the product of these ones. So I'm just going to say product. Okay, now let's now put the signs, the demarcation of signs. So which equation gave us a 1? The equation that gave us a 1, it is 1 minus x. So if I get 1 minus x, where there is 1 here, if we get any number that is less than 1 and we put in this equation, what are we going to have? Let's say I get a 0. 1 minus 0, I'm just going to have a 1, which is a positive number. So I'm going to have a positive number here. Then if I get any number between 1 and 2, let's say 1.5. 1 minus 1.5, that will give me a negative number. So this will give me a negative number. Even 2 will give me a negative number. If I get any number above 2, if I put 2 here, 1 minus 2, that gives us a negative 2. Or even just any number, 3, all numbers above, they're going to give me that. Now we come to the second one, 2x, which 2x, 2 minus x is the one that gave us a 2. So in this case, we're saying 2 minus x. Now our 2 is here. If we get any number that is less than 2 and we put in this equation, what are we going to get? Let's say we put even just 1. 2 minus 1, that will just be a positive number. So basically, I'm going to have a positive number here, and even if I get a number that is less than 1, even 0 here, I'm going to have still a positive number here. So I'm going to put positive there. Then if I get a number that is greater than 2, and I put in the equation, so if I put, let's say, 3 here, you're able to say that I'm going to get a negative number. So I'm going to have a negative here. Then now that I've got this and these ones were multiplying, I'm going to multiply the signs to see what I now get. Okay, so positive multiplied by positive, that will give me a positive. Negative multiplied by a positive, that will give me a negative. The negative multiplied by the negative, that will give me a positive. Okay, now what this means is that because we've said we want values that are greater than or equal to 0, and we know that numbers that are greater than or equal to 0 are positive numbers. So that is the range that we have. That is the domain that we want actually. Those are the x values that we want. So in this case, the domain for this function will be equals to you know that going this side is negative infinity, the other side is positive infinity. Okay, so want all the values from negative infinity. We're going to reach at 1. 1 is included, because if I put a 1 here, no, 1 is 1 going to be included greater than or equal to 0. Okay, yeah, it's fine. If I put a 1 here, it will be 1 minus 1, which will give you 0. Then 0, the square root of 0 is still 0. That will still be fine. So 1 is included. Then I'm going to put union. Then I come to the other side, 2. We come now to 2 from this range to going to positive infinity. 2 will be included as well. If I put a 2 here, that will give me a 0. And 0 multiplied by anything is going to be 0. Then the square root of 0 will just be a 0. So in this case, 2 also is included. So we're going all the way to positive infinity. So here positive infinity. That will be the domain. Okay. Then the range. What about the range? The range for this function. So look at what you have. In this scenario here, if we put a 0 here, 1 minus 0, 2 minus 0, 2 minus 0, because you're able to see that it's like from 1 to 2 going this side, everything becomes becomes it's still fine. But what if we check 0? Okay, going to the y values. If I put a 0 here and I put a 0 here, 1 minus 0 is 1, 2 minus 0 is 2, 2 multiplied by 1, that is 2. That is still fine. So the 0 can be included. Going all the way. But if we put a negative number, we've already tried negative numbers here. If we put negative 1 there, negative 2, or negative 1 also here, we're going to have positive numbers. We're going to have positive numbers. So basically, the only range that you can have here is from negative 0 to positive infinity. Everything is going to exist. But if you get any numbers, infinity, we always put this symbol because we don't know where infinity ends. So everything is going to exist like that. But if you get any number that is less than 0, okay, that is, let me say, those bigger numbers, like maybe say, let's say, okay, everything is just going to exist for this one, and the range is just going to be from 0 to positive infinity. So this is how we show for this one. Now that we've talked about radical functions, what about rational functions? So rational functions are fractions. F of x, let's say f of x is equals to we can say 4 over 2 minus x. Now what can make this fraction undefined? This fraction, for a rational function, just make sure that the denominator is not equals to 0. Okay, that is the only key. So in this case, what can make this denominator to be equals to 0 is 2. If I put, where there is x, if I put 2 there, I'm going to have 2 minus 2, which will give me 0. And 0 divided by 4 is undefined. So in this case, the domain for this function is just equals to real numbers. All real numbers are going to exist. X is a member of all real numbers. Or you're going to say x should not be equals to 2. But everything exists. Everything exists. But for the range, you're going to find the inverse for this function. So the inverse, we've been finding the inverse. Where there's f of x, you put y. So y is equals to 4 over 2 minus x. Okay, let's solve just a practical example. Let's say I've got f of x is equals to, let's say, x plus 1 over x plus 2. So how are we going to find the domain? In this case, you get what is on the bracket, you equate it to 0. So x plus 2 should not be equals to 0. X should not be equals to, when I take the 2 to the other side, it becomes negative. X should not be equals to negative 2. Anything can exist, but x should just never be equals to 2. We want all the numbers, but we just don't want negative 2. That's what that means. Okay. Then the range, we are making x is subject to the formula in this case. So x plus 1 over x plus 2. So in this case, we're going to cross multiply. So I'm going to have x plus 1 is equals to xy plus 2. So because we're making x is subject to the formula, I'm going to put the values with x on one side. So I'm going to have x, this negative, the xy is going to go on the other side, and it's going to become negative. So I have negative xy is equals to positive 2. When I take the 1 to the other side, it becomes negative 1. Then from here, I just have to factorize the x 1 minus y is equals to 2 is equals to 2 minus 1 2 minus 1 in this case, 2 minus 1 in this case, okay, I think there was a mistake here. Y multiplied by x, that is xy, then y multiplied by 2, that is 2y. Okay, so this is 2y, this is also, I can put the y there, so 2y minus 1. Okay, then 1 minus y, I'm going to divide it on both sides, 1 minus y. So x therefore is equals to 2y minus 1 over y minus over 1 minus y. So that is what we have. Now what this means is that this that we have as a denominator where y is, just equate it to 0, because we don't want that to be equals to 0. So y, 1 minus y should not be equals to 0. Okay, so negative y should not be equals to, when the 1 becomes, it goes on the other side, becomes negative. So therefore y should not be equals to 1. Okay, so want all the values of y, but we just don't want 1. Okay, basically that, but everything exists. So y is a member of also real numbers, but y should not be equals to 1. That is the range. So basically we've talked much about the range and the domain, and I'm sure that has given you a glimpse. Now what about composite functions? So when you have a function and you have a function in that function, that is a composite function. In other ways, we're just talking about a function of another function. So let's say I've got f of x. I've got, let's say, f of x is equals to 2x minus 3. Then I've got g of x is equals to 2x minus 1 over 3 minus x. So here, what are we going to do? Let's say they've asked us to find f of x. Let's say they've asked us to find we can also say f3 of x. We can also, you can also try fog of 2. Basically that. So how do we solve this one? So if we're going to solve, because what this means is that if I've got for f of x, get the function of f of x and replace it in the function of f of x. So that's what that means. That's why these ones are composite functions. So let me first write this function, which is f of x, which is 2x minus 3. Then wherever there is x, I'm supposed to put f of x. Okay, f of x is still the same thing. So I'm going to say 2, where there is x, I'm going to put 2x minus 3. Don't forget there's a minus 3 here, so put the minus 3. So when I now solve this, I'm going to have 4x minus 6 minus 3. So this will give me 4x minus 9. So that is our answer. Okay, then if you are going to find let's say this one, the last one, so we're trying to find the fog of 2. So fog of 2, first find what g of 2 is, then you get the function for f of x, then wherever there is x you put the function for g of 2. So this is quite involving, but it's still simple. So we're going to get the function for g of x. Wherever there's x, we're putting 2. So g of 2 will be equals to 2. Where there's x, we're putting 2 over 3 minus 2. Then we solve. 2 multiplied by 2, that is a 4, minus 1 over 3 minus 2 down, that will give us a 1. 4 minus 1, that is 3. Divided by 1, that is just a 3. So that is what g of 2 is. It is a 3. Then you have to go back and find and just replace there. So what is f of x? Or f of x? F of x in this case is 2x minus 3. Then wherever there is x, we replace g of x. That's what that means. So I'm going to have 2. X will find that it is 3, or g of x, which is 3 minus 3. 2 multiplied by 3, that is a 6, minus 3. That will give us a 3. So that is how we solve that one. Okay, so basically that. Now let's just talk a bit about quadratic functions. Now a quadratic function, okay, so basically talking about completing the square before you even talk about quadratic, because we've talked much about quadratic functions. But now when you're completing the square, this is still a quadratic function. Okay, but they're going to come again in front. We're going to talk about how you graph quadratic functions. So completing the square, how do we complete the square? So you know that a normal function is f of x. A normal quadratic function is f of x is equals to ax squared plus bx plus c. Now when you're completing the square, in this case, you want your answer to be in the form of a x plus p squared plus q. So that is the form that you want. So for us to attain that form, you're able to see that the a is outside. So even from my expression here, we have to factor out a. Now if I factor out a of a, I'm going to remain with x squared there plus b over a. Then there's x plus c over a. So I want, when I multiply again with a, it takes me back there. Okay, that's why we've put it like that, so that when you multiply by a, that side is going to remain like that. Where these a's, this a is going to come here, it's going to cancel, it's going to come, and it's going to give us this answer. So that is the basic of everything that you're going to be doing on this one. So now, what is a half? You have to first, now you're going to half this coefficient of x. Now what is the half of b over a? So multiply by half. You're going to have b over 2a. Then to this one, you're supposed to square it. Okay? So what we're now going to do is, I'm going to have a, I'm going to carry the a all along. So I'm going to have x squared plus b over a, there is x. Now this half, we're going to square it, subtract and add it. So in this case, I'm going to say plus, you are saying it is b over 2a. We're supposed to square it, and we're also supposed to subtract it. So that is b over 2a squared. So I've added it and I've subtracted it, the half that we found. Then plus c over a. Now that we've got this, we're going to ignore this part, the one that we halved. then we're going to get the squares, this one and this one. So, and we're going to put them in one bracket. So I'm going to have my a. So I'm going to have my x plus b over 2a. Since both of them are squared, I'm going to put the square outside. Then I've remained with minus b squared over. So if I'm going to simplify this, so it's going to be b squared over the 2. The square is going to be on the 2 and on the a. So that is like 4a squared plus c over a. So basically this is what we now have. Now that we've got this, if you want now, you can now further simplify this, and it gives you a very tangible answer where if you just find the common denominator. But now my interest here is, so this that is here, it is what we are calling the p, okay? Then this whole expression, when we solve it, is what we are calling the q. That is what we're calling the turning point, and this is the expression that we have there, okay? You have your a there, you have your x, then you have your p, which is b over 2a, you have your squared outside, and you have your q, which is that. So basically that. Now to just explain now this using let's solve an example. Let's say you are told to solve f of x is equals to x squared minus 4x. So what are we going to do? We are going to factor out the coefficient of x squared. In this case it is a 1. So if we factor out, what are we going to? We're going to have 1 x squared minus 4x. Then we're going to find the half of the coefficient of x, which is negative there. So the half of negative 4, so negative 4 multiplied by half, that will give us a negative 2, because 2 into 2 is 1, 2 into negative 4, that is negative 2. Negative 2 multiplied by this one just gives us a negative 2. So to 2, we're supposed to add, we're supposed to square it. So this is negative 2, we're supposed to square it. This is a positive 1 and the negative 1. Okay, so basically that. So now if I'm going to now express this, I'm going to have x squared minus 4x minus, or in this case I'm going to put a plus. So we're going to add this, so that is negative 2x squared. Then we're going to minus, okay, so that is minus 2x squared. Okay, basically that. Now that we've got this, what are we going to do? We're going to ignore this one, the one that we halved. So I'm going to have my 1 maintained. X is squared and this one is squared. So I'm going to put those ones in one bracket. So I'm going to have x minus 2. Then I'm going to put the square outside. Minus. So this is a minus. Then negative 2 squared, that gives me a 4. So that is our 4. Now you're able to see that now that is an expressed form. We've expressed it in the form of a, you know, x plus p squared even minus q or plus q. Okay, that is the form that we always want to attain. We've expressed it in that form. So now the turning point, if they've asked you to find the turning point and maybe to also draw or even show this on to graph it. So the turning point, let me write it in the far corner. We might want to use it. Excuse, the turning point for this equation. So it is always negative p comma q. So in this case is equals to, this is negative 2, then we are saying negative p, so the negative and the negative are going to give you a positive, so we have a positive 2 comma q. You are just going to get it the way it is, which is negative 4. So that is where the graph is going to turn from. That is our turning point. Okay, now that we found the turning point, we can find other other important features, like a graph should have intercepts if it has. Okay, so let's try to find out if it has intercepts. Okay, just a minute. Where can I rub? Okay, I can rub the other side. Maybe I might want to use this information. So now, for us to find the y-intercept, you know, on the y-intercept, it's just that place where you're cutting the y-axis. On the y-axis, x is equals to 0. So we're going to get the function, and wherever there's x, we're going to put 0. So it's going to be f of 0 will be equals to 0 squared minus 4, 0. Okay, in this case, we're just going to have a 0. Okay, since we have 0, so meaning the y-intercept is 0 comma 0. Okay, now what about the x-intercept? Where the graph is cutting the x-axis, we have to set the whole equation to be equals to 0. Now, goodness enough, where is the equation? It is this one here. Okay, so allow me to rub this side. We can rub this equation. Okay, so on the x-intercept, y is equals to 0. So this is the same as y. So I'm going to say 0 is equals to x squared minus 4x. Now that we've got this, what do we now do? I'm going to factorize x. So I'm going to have 0 is equals to x minus 4. Okay, then you know what this means. Every time you have a 0 this side, and you have, factorized like that, this means that x is equals to 0, or x minus 4 is equals to 0. So x in this case will be equals to 4 when the negative 4 goes on the other side. So we've got two answers. X is equals to 0, x is equals to 4. That's where we're cutting the y in the x-axis. Okay, now that we found this, we've got everything that we need to graph our function. So if let's say this is our graph, and we put it like that, okay, so to put our numbers, we've said the turning point, it is at 2 comma negative 4. So if I'm going to put 2 here, and I put negative 4 somewhere here, meaning our turning point will be somewhere here. Okay, then where are we cutting the y-axis? It's 0 comma 0. Okay, 0 comma 0 is somewhere here. Let me use the red color. So 0 comma 0 is there, 2 comma negative 4 is there. Then what other point do we have? We're saying this graph is cutting the x-axis at 0, which is, we've already shown that. It is also cutting it at 4. Okay, we can put 4 somewhere here. That's where our 4 is. Okay, basically that. So you're able to see that this graph now is a bit we can now join the points to show that it is a graph. So it's coming that side, okay, so it has to pass through the points nicely. Okay, basically that. So this is f of x is equals to x squared minus 4x. So that is the graph. Then the point here, the turning point is 2 comma negative 4. So basically that. Then a clue, a, if your a, in this case your a, the coefficient of x squared, if it is greater than 0, let me say if it is a positive number, you're going to have a minimum point like that. But if it is less than 0, let's say it's a negative number here, where the negative is going to be a maximum. It's going to be something like that. So that is another pointer that I just sort of passing through. Very important. Now that we've talked about completing the squares, how do you solve modulus functions? Now, a modulus function, it is also known as an absolute function, because here we're going to be dealing with absolutes. So an example is the way we define a modulus function is if I've got, let's say, the modulus of x, this is equals to x. The condition is if your x is greater than or equal to 0. Then x is equals to also negative x only if your x is less than 0. So what we mean here is that the modulus can never be negative. The modulus of a number can never be a negative. You only want positive numbers. So for example, the modulus of 5, that will give me 5. Mind you, these ones that I'm putting, or the bars I'm putting, these are what we are calling the absolutes. Okay, so that is equals to 5. The modulus of negative 3, what is it going to give us? It's going to give us a 3. So whether it's negative, whether it's positive, the modulus of 0, that will give us a 0. So that is the modulus. So you square the number, then you square the root, then you square root the answer. So that's the same thing. That's why you're able to get the same positive number. So an example, let's solve another equation. So negative 3 minus 4 modulus. How are we going to solve this one? So we are going to negative 3 minus 4, that is negative 7. The modulus of negative 7, it is 7. So that's how we solve that one. Let's say you have modulus minus 3 minus modulus minus 4 modulus, then modulus. How are we going to solve this one? Start with the one that is in the modulus. So I'm going to have minus 3 minus the modulus of negative 4, that is a 4. Then put the modulus. Then negative 3 negative 4, that is negative 7. The modulus of negative 7 is 7. So that's how you're going to solve that one. Let's solve the last one. Let's say you're trying to find the modulus of 2 minus modulus 4 minus 3 modulus minus 3 modulus 2 minus 7 modulus. Okay, so this is interesting. So how do we solve this one? So let's solve what is the modulus first. So I'm going to have 2, okay, minus 4 minus 3, it is a 1. The modulus of the 1 is 1, so I'm going to put a 1 here. Minus 3. 2 minus 7, it is negative 5. The modulus of negative 5 is, the modulus of the negative 5 is what? Is a 5. Then put your modulus like that. Then we solve. So we've got 2 minus 1 minus 3 multiplied by 5, that is a 15 modulus. Then we solve again. 2 minus 1, that is 1. Then 1 minus 15. 1 minus 15, that is negative 14. The modulus of negative 14 is just 14. So that will be our final answer. Now, how do we sketch modulus functions? Okay, so these are one of the simplest functions are very easy to sketch. So if I've got f of x is equals to modulus of x, how do I solve this one? So since this is when we're just starting, let's use a table of values. Okay, so we can pick even just 3 numbers. Let's say we start from 0, we start from 1, 0, we can even put negative 1 there. Okay, now wherever there's x here, we'll be putting these values that we've put there. If I put a 1 here, the modulus of 1 is what? It is a 1. If I put a 0, the modulus of a 0 there is what? It's a 0. If I put a negative 1 here, the modulus of a negative number is what? It is still 1 in this case. So you're able to see that it's just giving you the positive y values. So now if we're going to graph this, let's say this is our y-axis, this is our x-axis. So let's say I've got negative 1 here, I've got 1. So 1 comma 1, let's say we have another one here. 1 comma 1 will be somewhere here. 0 comma 0, it will be somewhere there. Let me use a different color for the points. So we've got this point and this point. Then we've got negative 1 comma 1. Negative 1 comma 1 is somewhere here. So able to see that the graph for this one looks something like comes this side and passes that side. So that is the graph for f of x is equal to the modulus of x. So that is the thing. Now what can I also just hint here? So look at first the value of the modulus itself and the value of the whole function. So x inside is positive, so you're going to the positive values of x. Then the value of the function, it is also positive here. There's no negative there, so you're also going to the positive values of y. So values this side, all of them are positive values of y. Okay, because you've got 1, positive 1 here, positive 2. You're going to have positive values of y going up. But you can only have negative numbers, negative values of y when you have that. So that's what we mean here. So basically that. So let's solve another modulus question. Let's say this time around you have f of x is equals to negative x, like that. Negative modulus of x. So how are we going to solve this one? So able to say the value of the whole function is negative and we find the modulus of x. So basically we are going to write like that. That will be our modulus. Basically that. Now if let's say we have f of x is equals to x minus 2. How are you going to solve this one? So for this function, it means x is going to start at 2. Why is x going to start at 2? It's because we have a shift in the x direction. So because of that shift, we're going to have x minus 2 to be equals to 0, so therefore x will be equals to 2. So we've shifted 2 units. So now if we're going to now draw our graph, so let's say this is our graph like that. So if 2 is here, so it means our graph is going to go like that and like that. Why it's going to go like that is because look at the value of the whole function. The value of the whole function is positive, even if they haven't put for us. Okay, then the value of x is also positive, so we're going to the positive values of x and the positive values of y, and that is how it's going to look. But we have a shift in the x, which is that. Now look at the nature of our graph. We've cut this part, so because we've cut that part, we have to find the y-intercept. So on the y-intercept, what is x? On the y-intercept, x is equals to 0. So I'm going to get the whole function and replace wherever there's x, I'm going to put 0. So f of 0 will be equals to the modulus of 0 minus 2. Okay, then 0 minus 2, that is minus 2. The modulus of 2, it is a 2. So meaning the y-intercept, this point here, it is 0, 2 as the y-intercept. When you have done that, you've completely simplified. Okay, so the same question, if let's say there was a negative there, there was a negative here. If there was a negative here, instead of the way our graph looks like, it would have gone down. Why is it going down? It's because the value of the function is negative. We're going to the negative values of y and the positive values of x. At the end of the day, look at it's negative. So the where are you going to find the negative values of y? Here, that's why I have negative 1, negative 2, negative 3. That's why it's facing in that direction. So when it's going to cut this area, so if this was positive 2, this would be negative 2. So in this case, it's just like a reflection of what just happened. So basically, this is how you sketch modulus functions. Then sometimes you can also be told to sketch a quadratic modulus. Okay, we've talked about how you find quadratic functions. That is no brainer. But now, how do we solve a quadratic modulus? So an example of a quadratic modulus is, let's say we have f of x is equals to, let's say, the absolute value of x squared minus x minus 6. So how do you solve such a one? So get what is in the modulus first, solve it using completing the square. That will help you to graph, then solve the modulus. So in this case, we have f of x is equals to x squared minus x minus 6. So now that we got that, I'm going to factorize the 1. I'm going to remain with my x squared minus, then the coefficient of x here, it is 1. Oh, it's negative 1 actually. It's negative 1, this one. So we're supposed to find the half of negative 1. So I'm going to multiply this by half. So I'm going to have negative 1 over 2. So this is what we have. And we're supposed to square it. And if I square it, what do I have? I have negative 1 squared is 1. 2 squared, that is a 4. I've got that. So basically, this one that we've squared, this one that we're going to put where there is negative x. So let me just write it, negative x. Then we're going to add plus negative half. This is squared, and we're going to subtract the same one. Negative half squared. Okay, then don't forget we have a minus 6. You put it there. Yeah, then you solve. So we have a 1. Now we're going to ignore the one that we've halved, which is x. Then we're going to get this one which has a square and this one which has a square. We're going to put them in one bracket. So it will be x minus half, then this will be squared, minus, then we're supposed to solve this. We've already solved it, which is here. So yeah, we've already, so it will be 1 over 4 minus 6. Okay, yeah, this will be like a plus because of that square like that. Now that we've got this, what do we now do? We can now solve this expression that is there. So if I say over 1 here, I say 4. 4 into 4 is 1, minus 1, minus 4. No, 4 into 4 is 1. 1 multiplied by 1 is 1. Okay. Then 1 into 4 is 4. 4 multiplied by 26, that is like 24. Okay. So negative 1 minus 24, that is negative 25. So here I'm just going to put negative 25 over 4. So this is negative 25 over 4. Then I've got an expression here. 1 x minus half squared. So basically this is what we have as our answer after we solved it. So from here, what is the turning point? What is the intercept? So that we graph. So the turning point for this one, we are saying the turning point, to find it as negative p over q, right? Okay. So in this case, what is our negative p? It is negative half there. Because it's negative, so I'm going to put, it's going to be positive half. Comma. What is our q? Our q is negative 25 over 4. Okay, that is what we have for now. So let's find the x-intercept and the y-intercept. On the x-intercept, y is equals to 0. So since y is equals to 0, so it will be 0 is equals to, I'm going to get this expression from there. It's like we solved it and we've reached almost close. So that will be x minus half, this is squared, minus 25 over 4. Then all we just have to do is solve this, because on the x-intercept y is equals to 0. So I'm going to take the negative 25 over 4 on the other side. It becomes positive. So I'm going to have 25 over 4 is equals to x minus 1 over 2. Then there's a square that side. For me to cancel the square, I'm going to square root on both sides. This side and that side. So this, the square and the root are going to cancel on this side. Then what is the square of 25? The square root of 25. That is a 5. The square root of 4, that is a 2. Okay? This is positive or minus. This will be equals to, we remained with the x minus half. So we're going to take the half to the other side. Okay? So therefore x now will be equals to positive 5 or minus 2, positive or minus 5 minus, okay, let me write it like that. The half is negative half. When it goes on the other side, it becomes a positive. So it's positive half. So I'm supposed to add and subtract that. Now, if I'm adding and if I'm subtracting, what do I have? So there's, I'm going to have so let's start with x is equal to minus 5. X is equals to minus 5 over 2 plus half, or x is equals to positive 5 over 2 plus 1 over 2. Okay, allow me to rub this. So therefore now our x will be equals to, since the denominator is the same, I'm just going to get 1 2. Then negative 5 plus 1, that is a negative 4. So that is one value of x, negative 4. Or another value of x, since we have the same common denominator which is 2, I'm just going to get 2. Then I'm going to add 5 plus 1, that is a 6. Then I can divide 6 into 6, 2 into 6, that is a 3. So those are the values of x. Then I can also simplify the other one on the negative 4 divided by 2, that is a negative 2. So those are the values of x. So allow me to rub this part. We found the values of x. Okay, so these are the values of x. Okay, then we're now supposed to find the y-intercept. On the y-intercept, on the y-intercept we know that x is equals to 0. So in this case f of x is equals to, we're going to get the whole equation is x squared minus x minus 6. So wherever there is x, we're putting 0. 0 minus 6. So just going to be negative 6. So the y-intercept, y, in this case, the y-intercept, it is at 0, negative 6. So that is what we have. Then allow me to wrap this part. So we found everything that we need for graphing. Okay, so now let's say this is our graph. Okay, something like this. Then we now put our values. So what was our turning point? Our turning point was something like half, negative 25. So let's say half, let's say 1 is somewhere here, then half maybe is just in this line. So let's say half, then negative 25 over 4, that is like somewhere like 8. Let's say somewhere let's say somewhere here. Okay, that is like negative 25 over, let's say this is negative 25 over 4. Okay, if you are going to divide it, maybe it's going to be close to like 8 point something. Okay, 8.5 somewhere there. So that is our turning point. Now where are we cutting the x-axis? We're cutting at negative 2. I can put the negative 2 here, and I can put the 3 here. Okay, so the points that we have for now is this one, the turning point there, and the x-intercept. Now where are we cutting the y-axis? We said we're cutting it at negative 6. So since this is in like negative 8.5 somewhere there, let's say our negative 6 is somewhere here and there. That's where we're cutting the y-axis. So we're just supposed to join these points. Okay, so if I join them, be something like that. Okay, something like this, passing through all the points. Okay, I've managed to get it like that. Okay, now that we found that, we are done graphing our quadratic function using completing the square. But now we are lacking one thing now. Now there's an aspect of the modulus. This question is in a modulus. So what do? You know that you can't have negative numbers for this, because you look at the value of the whole function is positive and the value of x is also positive. You are going to the positive values. So in this case, everything that is negative has to be reflected. So cutting here, everything going down is negative. So we are going to reflect that upwards. So in this case, how is our graph going to look like? This turning point, which is here, we have a 6 here. So we're going to put a 6 again on top here. Then we have this point, half comma, they say half is the half comma negative 25, or they say somewhere here it's a point on top there. Okay, so this graph is going to be reflected like that. Okay, whatever is down is going to be rubbed. So we're going to rub with that part and that part. Okay, so that will be our graph now. Negative 2 here, 3 there, and yeah, that is positive now, 25 over 4 there, like that. So this is how you solve a quadratic modulus. Not very complicated, like that. Let's talk about rational functions. Now, how do we sketch rational functions? We've talked about rational functions being fractions. So if I've got f of x is equals to negative 2 over x squared minus 4, how are we going to sketch this one? So for rational function, you have to find what we call the vertical asymptote and the horizontal asymptote. An asymptote is that part on the graph where you're not supposed to touch. So now vertically, where are you not supposed to touch? So for the vertical asymptote, you equate the denominator to 0. So let's find the vertical asymptote. So for the vertical asymptote, let's equate the denominator to be 0. X squared minus 4 is equals to 0. If we solve this, it is x squared minus 4. I can also rewrite it as 2 squared, right? It's still the same. So if it is still the same like that, this is a difference of 2 squares. So I'm going to have x minus 2, x plus 2 is equals to 0. Then I can equate x minus 2 is equals to 0, or x plus 2 is equals to 0. Therefore x is equals to the negative 2 when it goes on the other side, it becomes 2. The 2 when it goes on the other side becomes negative 2. So those are the vertical asymptote. Those are the lines we are not supposed to touch on the x-axis. Now how do we find the horizontal asymptote? For you to find the horizontal asymptote, look at the power of x. If the power of x on the denominator is greater than the power of x on the numerator, the vertical asymptote, the horizontal asymptote will be at y is equals to 0. Okay, so that is what we have. So if this is what we have, so the equations, we've got x minus 2 and x plus 2. Okay, good. So the horizontal asymptote we're saying is that y is equals to 0. Now we've gotten two values of x. We still need to come up with a table of values to see where our regions lie. Okay, so we're going to come back again with those tables. So I'm going to write that table of values. Want to find where these regions themselves lie. Okay, so we can put it like that. So for the first equation, for the second, okay, we only have two equations, so this is enough. So So now we can now put our values. So for x we found two values, so there's negative. Always start with the smallest number. So in this case I've got -2 and I've got 2. Okay, which equations gave us these answers? We had x minus 2 and x plus 2. Then these ones were multiplying to give 0, so we were finding the product. Okay, so let's now put the signs. If we're going to start with x plus 2, x plus 2 is the one that gave us -2 when we equated it to 0. So if we get any number that is less than -2 and we put it in this equation, what do we get? So if I put, let's say, -3, it will give me a negative answer. So here I'm going to have a negative. Then if you get any number between -2 and 2, let's say a 0, if we put a 0 there, what are we going to have? We're going to have a positive number. So we have a positive there. Then if we say we get any number that is greater than 2, let's say a 4, we are still going to get a positive number. So we have a positive number in this region. Now we come to the one for the negative. So we come the one for the negative. So allow me to just rub this. Okay, so we have x here. Okay, so we come to the x minus 2 is the one that gave us +2. So let's say we have a -2 here now. So if you get any number that is less than 2, we put it in this equation. What do we get? If we get any number, let's say we get a 0 here. If you put a 0 there, we're going to have a negative number. Okay, so you're able to see that this is going to give us negative numbers because those are less than 2. Then if you get any number that is greater than 2, let's say a 5, we're going to have a positive number, so positive there. Then now that we've got this, we just now have to find the overall signs. So negative multiplied by negative, because these ones were multiplying, we're going to have a positive. Positive multiplied by negative, we're going to have a negative. Then positive multiplied by positive, that will give us a positive. So that is what we have. So basically, if we've got that, now we can graph our function. So if I'm going to draw it like that, and this side like that. Okay, so now let me put my asymptotes. Let me start with my vertical asymptotes. We said we're not supposed to touch these lines, so let's say this is -2 and another line here, this is +2. We are not touching those lines. Then the horizontal asymptote, we said it is at y is equals to 0. Y is equals to 0, it is this line, the x-axis. Okay, that is the x-axis. Y is equals to 0. So now that we've got this, we're supposed now to show where the graph is going. Now here is how we're going to be comparing. We always compare with the one that is on top, that is -2. So look at in this region, from here, from this region where from -infinity to -2, that is that region. Then between, it is this between. Then the last part, it is this part. So that's how we'll be going. So let's start with this one as a positive, this one as a negative. When we divide them, we're going to get a negative number, right? So meaning our graph is going to go there in the negatives. Okay, we come on the middle. The middle here we have a negative, here we have a negative. So because we have a negative, they're going to divide, so we're going to have positive. So we're going to go like that. But if it was negative, would have gone like that. Since it's positive, it will be like that. Okay, then for the last one we have a positive and a negative, so it means we're going to go downwards for the down part. So we're going like that, not touching the asymptotes. So basically this is how you graph this. The domain, you know that it's just these values from negative infinity. If I'm going to put negative infinity this side and positive infinity, the domain will be from negative infinity to 2, from 2 union to negative 2 to 2, just reach region until you reach to the last part. So what do I mean? So the domain for this function will be equals to, so we are going to start from negative infinity to 2. Okay, then we're going to say union. We're going to have negative 2 to 2, then we're going to have union again. We're going to have 2 to positive infinity. Okay, basically that. Then the range, the y values. Okay, so the y values, look at that. So we're not touching the x. We've said we're not touching this the x-axis. So because we're not touching the x-axis, it means the y values, all the y values we're getting, they are from we're getting only from 0 to positive infinity. Okay, actually, yeah, everything will just exist. Like from negative, this is coming from negative infinity, is going to positive infinity like that. However, it's going to pass through this turning point. Okay, so that is from the range of this function will be equals to, from you are moving from negative infinity to 0 union, there's a turning point here, so turning point to positive infinity. The way I find the turning point for this one, just get the whole equation that we had and you differentiate it. But now we're not talking about calculus, but yeah, just for illustration's sake, that is how you solve that one. So this is how you solve rational functions and sketching them. Okay, then how do we solve rational equations? So the way we solve, let's say I've got 2 over x minus 1 is equals to 3 over 2x minus 3. So here you just cross multiply. It's not even complicated. And so this 3 is going to multiply with that, the 2x is going to multiply with that. So 3 multiplied by that, so that would be 3x minus 3. This would be equals to 2 multiplied by this, that would be 4x minus 2 that is minus 6. Then when you do that, you just put the like terms together. So this would be 3x minus 4x is equals to negative 6 plus 3. Then 3x minus 4x, that gives us negative x. This would be equals to negative 6 plus 3, that gives us a negative 3. Therefore x is equals to 3. So this is how we solve. Very simple, not complicated. But how do we solve rational inequalities? Now these are the tricky ones because they are a bit different from for the rational equation. For rational inequalities, I must make mention that you're not allowed to cross multiply. So let's say you're given to solve 1 over x plus 1. Let's say this is greater than 2 over 3 minus x. So we have an inequality there, so you have to be careful. So an equation, we put an equal sign, but an inequality, we put an inequality symbol. In this case the greater than. So what you're going to do, since we're not allowed to cross multiply, take this one to the other side. Okay, so when I take it to the other side, I have 1 over x plus 1. It changes the sign to negative, so negative 2 over 3 minus x. This is greater than 0. Now that you've got that, you are going to merge your fractions. Okay, so in this case, I'm going to get the common denominator, which is x plus 1, then 3 minus x. Okay, basically you solve now the way we are solving for a rational function. It's like you're just now cross solving this one, multiplying with that one. Then you get this one, you multiply with that one. So that is what is going to happen. Now when 1 multiplies with 3 minus x, because it's just 1, and I'm just going to have 3 minus x. The negative 2 is going to multiply with x plus 1. Negative 2 multiplied by x, that gives us negative 2x. So I have negative 2x. Negative 2 multiplied by 1, that will give us negative 2. Okay, now that I've got this, I'm just supposed to now, so this will be x plus 1 down, the other one will be 3 minus x. Now I'm just supposed to solve what is on top. So 3 minus 2, that is a 1. Then negative x minus 2x, that is negative 3x. So this is what I have, and we're saying this expression is greater than 0. Then because I've got all these equations, we have to find where our solution set is going to be. So from this point now, we're going to equate everything to be equals to 0. So I'm going to have 1 minus 3x to be equals to 0. And if I solve this, what am I going to have? I'm going to have 1 is equals to 3x. And for me to remain with my x, I'm going to divide by 3 on both sides. So x is equals to 1 over 3. So this is one x value. Another x value is, we're going to get x plus 1, also equate it to 0. So x will be equals to negative 1. Then we're going to get the last one, which is 3 minus x. We're also going to equate it to 0. So when I take x, negative x to the other side, x will just be equals to 3. So basically, those are the values that we found for x. Then look at, this is multiplying with that one and is dividing by that one. So whether you're dividing or multiplying, you're still going to get the same answer. So basically, let me now write my values down. So I've got x so we've got x is equals to 1 over 3. We've got x is equals to negative 1. We've got x is equals to 3. Okay, now that we've got this, let's now just come up with the, our table. Okay, like this. So which equations gave us? So we had the equation like 1 minus 3x. We had equation x plus 1. We had the equation 3 minus x. Then what about the numbers? So what were the answers? The answers are just down there. So I'm going to put them in terms of so we had starting from the smallest number. So we had negative 1. We have, allow me to wrap them. So we have negative 1, 3, and 1 over 3. So I'm going to start with negative 1 because it's the smallest. Then we've got 1 over 3, then we have 3. Yeah, then we now have to do our demarcation of signs. So for our equations, so let's start with which equation give us negative 1. So the equation that gave us negative 1 is x plus 1. So allow me to write it here, x plus 1. So if you get any number that is less than 1 and replace in the equation, let's say negative 2. So I'm going to get a negative number here. If we get a number between negative 1 and 1 over 3, let's say 0, I'm going to have a positive number. If we get a number between 1 over 3 and 3, let's say a 2, I'm going to have a positive number, Okay, now we come to the other equation. The equation that gave us 1 over 3. The equation that gave us 1 over 3, I'm going to write it here again. So it is 1 minus 3x. That is the equation that gave us 1 over 3. Now if we are here, if we get any number that is less than negative less than 1 over 3, let's say we get a 0. If we put a 0 here, what are we going to have? We're going to have positive numbers. So here I'm going to have a positive number, here I'm going to have a positive number. Okay, but let's say we get a number that is greater than 1 over 3. Let's say we put a 2 here. You're able to see that I'm going to have a negative number, right? So I'm going to have negative here and negative there. Then which equation gave us the 3? The equation that gave us the 3 is 3 minus x. Now for 3 minus x, let's see, see here. So for this one, if we get any number that is less than 3, let's say we put a 2 here, we're going to have a positive number. So this will be positive, this will be positive, and that will be positive. But if we get any number that is greater than 3, let's say we put a 4 here, we're going to have a negative number, so negative. Okay, now that we've done that, we said these numbers were multiplying and dividing, so even if we put a product or division, we're still going to get the same answer. So let me say the product. So what is our answer now? So negative multiplied by positive, I'm going to have a negative there. Then the positives are going to be positives. This one will give me negative, this one will give me positives. Okay, so that is what we have for now. Now since we want numbers that are greater than or equal to, that are greater than 0, mind you, when this one came on the other side, we remained with a 0 this side. So we just want numbers that are greater than 0. Numbers that are greater than 0 are positive numbers. So what region do we want as a solution set? We only want from here to there. This is positive, and from there to there, because positive numbers are greater than 0. So that is our solution set. So for our solution set, what is going to be our final answer? So our solution set will be equals to, so want from negative 1 to 1 over 3 union from 3 to positive infinity. We're going all the way to infinity for this one. Yes, basically that. So this is how we solve rational inequalities. Very simple and very straightforward. Now let's talk about alpha and beta, the ones we call the roots of a quadratic equation. So every quadratic equation you're going to solve, you're going to get two answers. Now let's say after solving a quadratic equation you get, let's say x is equals to 2, or even get x is equals to 1. Now the question will be, what equation gave you these two answers? To find that equation, it will mean we basically have to go back from the solutions to the equation. So what this means is that I'm going to take the -2 back and the 1 back the way they were. So x is minus 2. The other one would be x minus 1. I can even equate them to be equals to 0. Then now I can multiply x with everything. We're going back. So x multiplied by everything that is in the bracket, then the 2 multiplied by everything that is in the bracket. X multiplied by everything that is in the bracket, I'll have x squared minus x. 2 multiplied by everything that is in the bracket, I'll have negative 2x plus 2. This is equals to 0. Okay. Then what do I have? So I'm going to have x squared minus 3x plus 2 is equals to 0. So basically this is the equation where these answers came from. Okay. Basically that. Now the question will be, how about if you want to come up with an equation that will account for every general expression if you are given your roots? Your roots are your answers. So let's say after solving an equation now, you find let's say x is equals to alpha. Alpha is a Greek letter. Let's say beta, let's say x is equals to beta. Okay, so if you've got this, in this case x, alpha and the beta are the roots of the equation. The equation, we know that the normal equation it is ax squared plus bx plus c is equals to 0. But now, since these ones are the roots, are the answers, we're going to again take them back the way they were. We see what we have. So now I'm going to have x minus alpha. I'm also going to have x minus beta. This is equals to 0. Now if I've got this, what do I now have to do to... So I'm just going to solve like I solved that one. So the x is going to multiply with everything that is in the brackets. Okay. Then the alpha is going to multiply with everything that is in the bracket. Now let's say we solved it. When we solve this, I'm going to have x squared minus beta x minus alpha x plus alpha beta. This is equals to 0. Now if I've got that, let me factorize this part because I've got x here and I've got x that side. So if I factorize that part, I'm going to have x squared minus okay, so I'm going to start with the alpha, then the beta. So I'm going to have alpha plus beta, then I'm going to put the x that side, so that when you multiply x and alpha, x multiplied by alpha, it's alpha x, x multiplied by beta, it's beta x. Then there's a negative. There's a negative. When I multiply the answers that I'm getting from multiplying with x, if I multiply with a negative, I'm going to have the negatives there. That's what that just means. Then plus alpha beta is equals to 0. Okay, if this is what I have, now we know that our general equation, when simplified, so let me just rub this part. When we simplify our general equation is ax squared plus bx plus c is equals to 0. If we're going to simplify it, you know, it usually accounts to, you remove your a, then you are going to have x squared plus b over a, you have x plus c over a. This is equals to 0 like that. So now I'm going to write this expression just the way it is. down underneath the equation we're just from writing. So I'm going to have x squared here. I'm going to have x squared there. So I'm going to have x squared minus, I can put the a outside, it's fine, minus, I'm going to have not minus, plus. So I'm going to have plus b over a, then there's x plus c over a is equals to 0. Now you're able to see that now I can, if I want now, I can now let me first rub this. So this x and this x, they can go if I want. But now I'm able to see that negative alpha plus beta x is the same as this part. Then alpha beta is the same as that. So now let's just solve that now. So I've got negative alpha plus beta x, this is equals to beta over a, then there is x, or b over a. Then I also have this is equals to that. So I've got alpha beta is equals to c over a. Okay, that is what I have. So the x and the x can divide on the other side. Then the negative can divide and goes on the other side. So I'm going to have alpha plus beta is equals to negative beta over a. Okay, so this is the equation that I don't want you to forget. Then another equation that I don't want you to forget is this one. Okay, so what these equations talk about, this is when you're finding the sum of the roots. Okay, sum of the roots. This one we're talking about the products, because beta and alpha are multiplying. So that's what you're going to do. So if they've given you the roots, the general equation that you're going to use, we've been able to see it is x minus the sum of x plus the product is equals to 0. This is a general equation that you're going to be using. Okay, so basically that. So find the sum. If let's say x was equals to 2 and x was equals to 3, so the equation will be, for the sum, add the 2. Okay, if I add the 2, I'm going to put them there. Then for the product, I'm going to multiply these ones. I'm going to put my 6 there after I've multiplied. That will be the equation. Okay, so that is very important for us to understand. Then we know that the quadratic formula is about x is equals to negative, positive or minus the square root of b squared minus 4ac, everything over 2a. Now what we have in the bracket here, or in the root, this in the root is known as the discriminant. Now on the discriminant determines how the quadratic function is going to move. So it's going to tell us if the quadratic is going to cut the x-axis. All these depend on the discriminant. Now this thing that is in the root, which we are calling the discriminant, number one you should know is that if the discriminant itself, b squared minus 4ac, if it is greater than 0, this means you are going to have positive numbers, right? Because numbers in that root, you're going to have if you solve that in that root, you're going to have anything that is positive, maybe positive 2, you're going to have a positive number. So what does that mean when you have any number that is greater than 2 in the root? When you solve your equation, you're going to have two distinct real roots. you're going to have two different numbers. Distinct just means different. Okay, now if the discriminant is b squared minus 4ac, if, okay, even this one is 4ac, so if the discriminant is equals to 0, let's say in the root you get something that is 0. If you have that scenario, you have one real root. Okay, this means you have one real root. You are going to only have one answer. Okay, you're not going to have like x is equals to 2, x is equals to maybe -3. These are two answers which coming from the say first one, but for this one that we're just from doing, you're just going to have maybe x is equals to 1, only one answer. Okay, then for the third one is, what if now you have a negative number? So if b squared minus 4ac is less than 0, what does it mean? This means that you are going to have two complex roots. Okay, complex roots, we're talking about you having the square root of a negative number. It can be the square root of -2. So basically the square root of a negative number gives you a very big number, which is a complex number. Okay, so basically that. So it's very important for us to know those ones. Okay, then sometimes when you're solving alpha and beta problems, there's this expression that usually surfaces. So if I've got, let me say I've got alpha squared plus beta squared. So the way I'm going to solve this one is alpha squared plus beta squared. Don't make a mistake of saying it's the same as alpha plus beta, then you square it like that. Although it's close to this, but it's not like that. Okay, that is not complete. So it's going to be alpha plus beta. Yes, you square it, but you're going to add again -2 alpha beta. I don't want you to forget this. Okay, every time they give you such a problem, just replace this equation and solve. Why? Because alpha beta, you find it using the formulas that we just come up with. Then alpha multiplied by beta, you can also do the same. Then you just multiply that by 2. Then you're done. So now, how did we come about this equation? It is not guesswork. So if I've got alpha plus beta, let's say this is squared. Okay. How am I going to solve this one? You know that 2 multiplied by alpha, I'm going to have alpha squared. Then 2 multiplied by alpha plus beta, 2 multiplied by alpha is 2 alpha, multiplied by beta, 2 alpha beta. So I'm going to have plus 2 alpha beta. Then the square is going to fall on the beta plus. That's how we quickly solve quadratics. So basically that is what we have. Now if I take this on the other side, see what it's going to give us. I'm going to have alpha plus beta. This is the square is outside, minus 2 alpha beta. This is equals to, what are we going to remain with? We're going to remain with alpha squared plus beta squared. So we're able to see that this equation on top is equals to this same equation. That's why we're saying you can use that to solve. Okay, it will be very easier. Then another combination, what if now you have your alpha and the beta, they are cubed, let's say it's alpha cubed plus, let's say, beta cubed. So for this one, it's also not guesswork, but the way you're going to solve it, you're going to have alpha plus beta multiplying by alpha squared minus alpha beta plus beta squared. So that's how you solve that one. Then if you have, let's say, now alpha to the power 4 plus beta to the power 4. So for this one, just get the previous one, the first one that we just solved. So the first one was alpha plus beta, okay, squared, okay, minus 2 alpha beta. Now because it's to the power 4, you are going to square everything. Wherever there is a and b, square. So on alpha, wherever there is alpha and beta, square. So here I'm going to square, 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 and square. So for the last one, because both of them are squared, I can put the square outside. Okay. So basically that is for the fourth one. So let's have an example. Let's say if alpha and beta are real roots of a quadratic equation. Let's say the equation is x squared plus 3x minus 2 is equals to 0. Then we're told to find the value of, let's say, 1 over alpha squared plus, let's say, 1 over beta squared. So what are we going to do? Okay, so every time they ask us to find the roots, at least first find what alpha plus beta is and what alpha beta is. Simplify our work. So in this case, alpha plus beta, we know that it is just the same as negative b over a. Then alpha beta, it is c over a. Now what is our a, what is our b, what is our c? So from our equation, we're able to see that a is equals to 1, b is equals to 3, and c is equals to negative 2. Okay, now that we've got this, we just have to solve. So if I solve the alpha plus beta, it will be negative b is 3 over a is 1. So the alpha plus beta has just be negative 3. Then for our alpha beta, our c, it is negative 2, our a is 1. So this will give us negative 2 divided by 1, that is negative 2. So we have negative numbers. So now we just have to now come back to our equation and solve. So when we solve this, let's solve down first. Alpha plus beta, so we're going to come up with a common denominator, which is alpha squared and beta squared. Now when I multiply 1 into this, just give me that. Oh, alpha into this, the alpha squared is going to cancel. I'm just going to remain with the beta squared. And that beta squared is going to multiply with our 1 on top. So our beta squared plus the beta squared, when it divides here, I'm just going to remain with the alpha squared. The alpha squared will multiply with the 1 on top of alpha squared. Now that I've got that, because addition is commutative, I can put the alpha squared plus beta squared like that. Then I have alpha squared beta squared. Basically this. Then what did we say the alpha squared plus beta squared on top is? We said it can also be written as alpha plus beta, you square it, minus 2 alpha beta. It's very important that you understand that one. Then the alpha plus beta, the alpha multiplied by beta, because both of them are squared, I can get alpha and beta and I square them. Okay, basically that pretty much. Then since we've got everything that we need, we just need to now, replace and solve. So our equation, we've got alpha plus beta. What is alpha plus beta? This one. We've already found it. Alpha plus beta, we found that it is negative 3. So that would be negative 3. This negative 3 will be squared. Minus 2, we've got alpha beta. Alpha beta, we found that it is negative 2. Over alpha beta, we find that it is negative 2, then it is squared. So basically that, then we solve to find our answers. So negative 3 squared, that is 9. Then negative 2 multiplied by negative 2, that is positive 4. Over negative 2 squared down, that is a 4. 9 plus a 4, that gives us, is it a 13 over 4. So basically this is how we solve this type of problems. Not complicated. That's how we solve. Then how do we sketch quadratic functions? So like we said, we're going to also solve, we're also going to show how we solve quadratic equations. So a quadratic function is in the form, we know that it's ax squared, okay? Now if I've got, let's say we are sketching now, if I've got f of x is equals to, let's say, x squared. So how am I going to solve this one? So if this is our graph like that. Now like we've said, if your a is less than 0, if your a is greater than 0. So if it's greater than 0, it's a positive number, you're going to have a minimum. If it's less than 0, you're going to have a maximum. Okay, so that is the clue here. Now also look at the value of the function. So this one is positive here. They haven't indicated, but it's positive. So because everything is positive and the function is positive, you're going to the positive values of x and the positive values of y. So x squared looks something like that. Okay. Then what about f of x? Is equals to, let's say, negative x squared. Okay, so because the value of the function is negative, so we're going to the negative values of x. You're going to the function is negative, and we're going to the negative values of x. So this would be something like that. Okay, the opposite of the previous one. Then if we've got, let's say, f of x, let's say it is equals to x squared plus 2. So now the 2 in this case, it is a shift in the y. So basically, if you've seen all our graphs, we're starting from 0 here, but now because of the 2, we've shifted the graph on top 2 units. So meaning our graph is going to start at 2. Now at 2, we can either come down or go up like that. Now to go up or come down based on the values of the whole function. So we're able to see that x here is positive, so we're going to the positive values of x. And the whole function is also positive. So basically we're going to go like that on top, passing through that point, of course. Yeah, like that. So that would be our graph. So let's say again you have f of x, let's say is equals to negative x squared minus 4. So how are we going to solve this one? The 4 in this case is the shift in the y. So instead of starting at 0, now we're going to move 4 units down, which is 4 here. Let's say the point is there. Now the graph can either go up like that or the opposite. So how it's going to go up, and look at the values of x and y. So able to see that the value of the whole function is negative. Okay, and the value of the whole function is negative, and the value of x is also negative. So we're going to the negatives. So it means the negatives are going to be this side and that side. That's how our graph is going to go. Let's say I've got f of x is equals to x squared minus 3. So how are we going to solve this one? So not very different. You look at the value of the whole function, but we have a shift of 3 units. So we're going to shift 3 units. Negative 3 will be something somewhere here in the y. But now look at the values of the whole function. The value of the whole function is positive. The value of x also here is positive. So basically we're going to the positive values of x and y. That will be our graph. So you're able to see that every time, you know, it's not even complicated to solve these ones. So let's say we've got f of x. If you understand what is happening, very easy to just follow through. Okay, if you've got that, now we have a shift in the x. So because you've added 2 units to the x, what is it going to happen? Get what is in the bracket equated to 0. So x plus 2 is equals to 0. So x will be equals to negative 2. So that is the shift. We shifted our graph 2 units to the left of x. Okay, so we are initially supposed to start here, but x has been shifted at 2. So negative 2 is somewhere there. Then look at the value of the whole function. This is positive and x is also positive. So because both of them are positive, we're going up. Okay, so you're going to start from here, you're going up like that and like that. Now we've cut the graph that side, so at that point you're supposed to find that point. That point is the y-intercept. On the y-intercept, x is equals to 0. So f of 0 is equals to 0 plus 2 squared. So 2 squared. 2 squared, that is a 4. So this point that is here is 4. That is a intercept there. So basically it's very easy and straightforward to solve and sketch rational quadratic functions. Now, how do we sketch radical functions? So radical function have a root, like we've said in earlier sessions. So it can be a cube root, it can be an nth root, but as long as there's a root, it's a radical function. So for example, let's say you have f of x is equals to the square root of x. So how do we solve this one? So this one, because you also have to look at the value of the whole function and the value of x. The value of x here is positive and the value of the whole function is also positive. I mean, the value of x here is positive, the value of the whole function is also positive. So it goes like that. Okay, why? Because for this one here x is positive, y is also positive. Here x and y, x and y, x and y. Okay, so here x is negative, y is positive. Here both of them are negative. Here x is positive, y is negative. So basically that. So if you're going to look at this one, all of them are positive, that's why it's going like that. So if you're going to look at another function that has, let's say x is negative and y is positive, you're going in that direction. Okay, for this one you're going in that direction. For the other one you're going in that direction. So once you get this clue, then everything becomes simple. So let's solve another example. Let's say you have f of x is equals to, let's say, negative the square root of x. So you're able to see that y in this case it is negative, x in this case is positive. So if you're going to draw your graph, how is it going to run? Okay, so where is x positive and where is y negative? So it's in this region, so like that. Let's say I've got f of x is equals to, let's say, the square root of negative x. How is it going to run? So because y is positive, x is negative. So if x is negative, where is x negative and y positive? So x is negative this side and y is positive that side. So that's how you solve these ones. let's say I've got f of x is equals to negative the square root of negative x. How am I going to graph this one? So where is x negative, where is y negative? So it's in this region. So basically this is just how you solve them. What is just now going to differ is when they give you shifts. Okay, so f of x is equals to, let's say, the square root of x minus 4. So how are we going to solve this one? So equate what you have in the root to be equals to 0. So x minus 4 is equals to 0. So x will be equals to 4. So the 4 in this case is the shift. So basically our graph is always starting at 0, 0. But now you've shifted the x 4 units. So 4, let's say 4 is this side. Then you look at the value of the whole function. Y is positive, x is also positive. So it means from this point you're going this side. Okay, so that's how you solve this one. However, if we had the positive, if we had the positive there, so this would have been positive, this one would have been negative. So it means our graph would have gone on the other side. Negative 4 would have been this side. Then you look at the value of the whole function. The value of the whole function is 2 positive here for y and positive for x. So it is going to go in that direction. Okay, then you are supposed to find the intercept there. Now how do you find the intercept there? You're going to equate the whole equation to be equals to, because on the y-intercept x is equals to 0. So it will be f of 0 is equals to the square root of 0 plus 4. So it will be the square root of 4. What is the square root of 4? That is a 2. So you have a 2 here. So that's how you solve this one. And everything that is you're going to have is just about the shifts. So let's say I've got negative 3 minus x. How am I going to solve this one? Okay, so not very much different. Get what is in the bracket. So I've got x, we got 3 minus x is equals to 0. So when I take the x to the other side, it will be 3 is equals to x. So x is equals to 3. So it means if 3 is here, that's where our graph is going to start from. But in which direction? We have to look at the value of the whole function. You're able to see that it's negative. So y is negative. X is also negative. Okay, so it is negative. So we're going to the negative values. Where is x and y negative? You are going in that direction. Then you're supposed to find this point which we've cut. That is the y-intercept. On the y-intercept, x is equals to 0. So we're going to say f of 0 is equals to negative 3 minus 0. So that will be negative the square root of 3. Okay, so this will be something like negative the square root of 3, this point there. Okay. Okay, let's solve another equation, the last question on this one. Let's say for x, f of x is equals to 4 minus the square root of x. So how are you going to do that? The 4 in this case is a shift in the y. So now instead of shifting in the x, this time around we've shifted the y. So let's say this is our equation, this is our graph. Okay, so we have a shift 4 units to, so we're supposed to, we always start from here. So if you have a shift in the x, we're always going this direction or that direction. But now we have a shift in the y. So instead of just being here, now we're either going up or down in the y, on the y-axis. So this is 4. So for this 4, we are going up. So because it's positive. So I'm going to put 4 there. So that is our 4 here. Now the question will be, where are we going? We look at the value of the whole function. The value of the whole function, you're able to see that y there is negative. Then the value of x here is positive. x is positive. So you know that y, these are the negative values of y, these are the positive values of y. So in this, so this one is going in this direction. Okay, since it's going in that direction, you have to find where it's cutting that point. So it's cutting this point, that is called the x-intercept. On the x-intercept, y is equals to 0. Okay, so you get the whole function. So 0 is equals to 4 minus the square root of negative x. So for me to remain with my negative x, what am I going to, for me to remain with my x, I'm going to take the negative x with where 0 is. I'm going to have positive, the square root of x is equals to 4. Then for me to remain with my x, what do I now do? Allow me to write it on the other side. So the square root of x is equals to 4. I'm going to square root on both sides. So the square and the root are going to cancel. X will be equals to 4 squared, that is 16. So this point here is 16. So basically this is how you graph these ones. Very basic, not very complicated. Now how do you solve radical equations? So I've just shown a glimpse. If I have the square root of okay, let's say if I have the square root of x is equals to 1. This is an equation. How are we going to do that? Square on both sides, just like the way we were just from doing the previous one, is equals to also square 1. The square and the root are going to cancel, so x will be equals to 1. So that's how we solve that one. Let's say we have this equation, x minus 1 is equals to 3. So what are we going to do? Let's square both sides. So we have x minus 1, I'm going to square this, is equals to 3. Then this is going to also be squared. So the square and the root are going to cancel. So to be x minus 1 is equals to 9. So x is equals to 9 plus 1. X will be equals to 10. Okay, so basically that. Then you also, for radicals and modulus functions, you're supposed to check your answers. Okay, you're supposed to check your answers. So this 10, try to put it in the equation if you're going to see if it's going to balance. So in this case, I've got where there's x, I'm going to put 10. So 10 minus 1 is equals to 3. The square root of 10 minus 1, that is a 9, is equals to 3. What is the square root of 9? Positive or minus 3 is equals to 3. So in this case, the solution is only 3, okay, not negative 3. So that is the solution set. So that's how we solve these radical equations. Let's solve another equation. Let's say you have x plus 1 minus the square root of 2 is equals to 0. So for this one, take this one to the other side. So I'm going to have the square root of x plus 1 is equals to, when this one goes to the other side, it becomes positive. So I have positive the square root of 2. Then what am I going to do? I'm going to square on both sides. So the square and the root are going to cancel, x plus 1. The square and the root are going to cancel, I'm going to have 2. Therefore x will be equals to 2. When 1 goes to the other side, it becomes negative. So x will be equals to 2 minus 1, that is a 1. You have to check if 1 really satisfies the actual equation. So the actual equation is x plus 1 minus 2 is equals to 0. So we have x, that is 1. So 1 plus 1 minus the square root of 2. Okay. Then you're supposed to find that. So the square root of, so 1 plus 1 in this root, that is 2, minus the root of 2. So you're able to see that the root of 2 minus the root of 2, that will just give you a 0. So hence 1 is a solution. So the solution set will be x is equals to to 1. So basically this is how you solve radical equations. Then how do you solve radical inequalities? Okay, we've been solving a lot of radical inequalities since we just started. So an example that we can give is the square root of x squared minus 4 is greater than or equal to 0. So how are we going to solve this one? Get what is in the bracket, get what is in the root, and solve. So radical inequalities I didn't mention. So it's a mixture of a radical or a root and an inequality. Okay, so even here there is a root and an inequality there. So basically that. So get what is in the root and equate it to 0. So that is x squared minus 4 is equals to 0. Then after that, square now. X squared minus 4 squared minus 2 squared is equals to 0. This is just the same. Then it will be the difference of two squares. X minus 2, x plus 2 will be equals to 0. Then x minus 2 will be equals to 0. X plus 2 will also be equals to 0. Then x will be equals to, when the negative 2 goes on that side, becomes positive 2. X will be equals to, when the 2 goes to the other side, it becomes a negative 2. So those are our answers. Then what do? We come up with a table of values to just help us demarcate the signs. Okay, something like this. So let's say we have negative 2 here, we have 2 there. Our equations that give us those ones, we have x minus 2 and x plus 2. X plus 2. What are these ones doing? They are multiplying. So I'm going to find the product. Okay, basically this. Now we just have to now demarcate the signs. So this is negative 2. Which equation gave us negative 2? It is x plus 2. So x plus 2, if we get any number that is less than negative 2 and replace it in that equation, let's say negative 3, we're going to have a negative number. So I'm going to put negative here. If we get any number between 2 and negative 2 and 2, let's say 0, if we put a 0 there, I'm going to have a positive number. If I put a number greater than 2, let's say 4, that would be a positive number. Okay, then this equation gave us a 2, so we have x minus 2. So let me put x minus 2 here. If we get any number that is less than 2, let's say a 0, and we put a 0 there, what are we going to have? We're going to have a negative number. So negative, negative. If we get a number that is greater than 2, let's say 4, that will be a positive number. Then now we find the signs, we multiply. So negative and negative, when we multiply them, the product is positive. Here it will be negative, here it will be positive. Now that we have that, what do we now do? We find the solution set. Since we want numbers that are greater than or equal to 0, 0 is included. So in this case, what are we going to do? Numbers that are greater than or equal to 0 are positive numbers. So I'm just getting this region. This is a positive region going this side, and this is the other positive region going the other side. Okay, we're not getting the negative one because negative numbers are less than 0. Okay, so now that we got this, what is our solution set now? So the solution set is equals to, you know that going this side is negative infinity, the other side is positive infinity. So the solution set will be from negative infinity to negative 2. Is negative 2 included? Is negative 2 included? if I put negative 2 here and I square it, that would be a 4. 4 minus 4, it will be 4. It will be 4 minus 4, that will be 0. The square root of 0 is just 0. So that one is still fine. So we can still include 2. It's fine. It won't make the root to be undefined or the function to be undefined. Union. We come to the other 2. Even 2 here. If we put 2 here and we square, so 2 square, that is 4. 4 minus 4 still to be a 0. The square root of a 0 is 0. It's still fine. It's not making the function undefined. So we can include it. So this will be the solution set. So that is how we solve these ones. Okay. Now we also have to know how to find what we call piecewise functions. Okay, so a piecewise function, not very complicated. So a piecewise function is a mathematical function that is defined by multiple sub-functions, each applied to a specific interval or set of values. So you're going to have a function that has more than one function. So for example, if I've got f of x, this f of x is equals to, let's say, you're going to have several functions. I can have x plus 2. Then the range they're going to give me, the goodness with this one, they already give you the domain. Negative 1, that is a domain. Then 1, let's say I've got 1. Let's say 1 is between negative 1 and the domain is, that is the domain. Then I have x squared. Let's say I have x, in this case x is greater than 1. So that is the domain. Then we're supposed to see if the function is continuous or not. Basically that. So if I'm going to come up with table of values x and y, okay, basically that. So let's start with the first one. We graph this first one that we have on top. So we have x. We're saying x is less than or equal to negative 1. So because it is less than or equal to negative 1, so we can start from negative 1 going down. All the values that are less than negative 1, so negative 2, negative 3. We can get three numbers, it's fine. Then if I get, our equation is x plus 2. This is x plus 2. If I put negative 1 where there is x here, what do I have? I'm going to have negative x plus 2. Negative x plus 2, that just gives me a 1. So it gives me a 1. So I'm going to put the 1 there. So there is 1 here. Now if I put a negative 2 here, negative 2 minus 2, that will give me a 0. If I put a 3 here, 3 plus 2, that will give me, no, if I put a negative 3. If I put a negative 3 here, I'm going to have a negative 1. So basically, that is one of the graphs that we have. So allow me to just draw the graph in advance. Allow me to draw it on the left hand side, this side. Let's say this is our graph. Okay, we can put those values. So on, let's say negative, they have negative 3 here, we have negative 2 here, we have negative 1, we have 1, 2, 3. Then we have negative 1 here, negative 2, negative 3. Let's say this side we have like 1, 4, let's say 7, 9. Okay, so graphing this one, we just have to put these points that we have to graph the first the first function. So we have negative 1 comma 1 as our first point. So negative 1 comma 1, it will be a point somewhere, maybe somewhere that side. The negative 2 comma 0, it will be somewhere here. Allow me to use red, somewhere there, and this other one somewhere here. The negative 3 comma negative 1, it will be a point somewhere here. So able to see that these points are just joining. So allow me to join them. So that will be our graph for the first one. Then for the second one, let's come up again with a table of values. So we're going to have x again and y. So x, let's say this is x, this is y. Okay, so for x, what do we have as x? So what the range, the domain they've given us, x is between negative 1 and 1. So they've already given us, even easy. So we're going to start from negative 1, 0 and 1. Then let's find the values of y when it is that. Now you're able to see that all of them, they're giving us the value of 1. That's what that means. Okay, so that's what it means. So there's no much of solving. Everything is giving us 1. So here it's 1, 1, 1. So now we have to plot that. So we have to start with, I'm going to use a different color. So we have to start with negative 1 comma 1. Negative 1 comma 1. So negative 1 comma 1, it's this same point that we started with. Then we're going to go at 0 comma 1. 0 comma 1 is this one. Then 1 comma 1, it is this one. So basically we're just supposed to join those lines. Okay, then we come to the last equation, x squared. So again